Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abuzena. That special YouTube channel created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. I'm pleased to have you join us again today in our series of the topic sequence and series. In our previous videos before now, we have looked at the concept of arithmetic progression in its entirety, and we have resumed the topic geometric progression, which have been dealt with decisively in the last two videos by looking at the various aspects of the nth term of a GP. Today we continue in this streak by looking interestingly and in a fun manner at the sum of the first n terms of a GP. Right on, and let's have mathematical fun. So, the sum of the first n terms of the GP. The formula is given as a bracket r to the power of n minus 1 over r minus 1. This is used on the condition that the common ratio is greater than 1. It can also be given as a bracket 1 minus r to the power of n over 1 minus r. This is applicable when 1 is greater than r. So you must be able to distinguish when to use which formula. If you observe for the first one, when the common ratio is more than 1, you observe the common ratio is coming before 1 at both numerator and denominator. That's it, clear. Of course, this adds power n, there's no power n. Similarly here, if 1 is more than the common ratio, that means 1 comes before r in the formula. Okay. Let's see how to apply these formulas. Now, question 1. Find the sum of the first 18 terms of the sequence. And we got here 3, 6, 12, and so on. Okay. So without missing words, this sequence is GP. How do I know? By division, 6 over 3 is 2, 12 over 6 is also 2. That means there's a common ratio, which makes it a GP. So let's take our parameters. A is 3, common ratio is 2. That's a GP. Now to find the sum of the first 18 terms, just the first 18, not the entirety. So we're going to say n in this case is 18. So the formula to use in this case will be the first one. Because when you compare the ratio with 1, the ratio is more than 1, greater than 1, because the ratio is 2. So we're going to say we are bringing forth the formula Sn equals a bracket r to the power n minus 1 over r minus 1. So just substitute the letters a, r, and n accordingly. So in other words, we're looking for the sum of the first 18 terms. A is 3, r is what? 2. Which power 18 minus 1 over 2 minus 1. So if we simplify this further, we have 3, 2 power 18 minus 1. 2 minus 1 is just 1. And the formula, the answer is sum for the first 18 terms is simply 3, then 2 power 18 minus 1. With anything over 1 is actually that value. And that is actually the end of the solution to that problem, which I think is quite straightforward enough. Okay, let's take number 2. For number 2, we have that we need to compute 1 over 256 plus 1 over 128 plus 1 over 64 plus 512. Look at that question. Let's compute. This is not a sequence. Remember from our very first video of this series, it's actually a series because we are replacing the commas with plus sign, submission. So now we have to compute. In other words, it's a GP simply because I know A is 1 over 256 and R is simply 128 divided by 1 over 2566, which equals to 164, 1 over 164 over divided by 1 over 128. So when you do this, you're going to have 2 as a common ratio. So it's a GP really. So the question now is, what is the number of terms in this? Because when you have to compute, it simply means add up from the beginning, that's the first, to the last. That's the entire series. But we can't compute really without knowing n, because we look at the formulas, either one, n is required. So we need to first go and determine what n is. And how will we do that other than using the formula for n times for the GP? Recall Tn is a r power n minus 1. And don't forget, Tn represents what? The last term as well as the nth term. So the last term here is 512 equals to a is 1 over 256. And r, as I have said, is 2 raised power n minus 1. So this is basically indices we are dealing with here. 512 equals to, this is actually 1 over, this is 2 raised power 8. This raised power 8 there, then 2 raised power n minus 1. So we have 512 is actually 2 raised power 9. So we have what there? 2 power minus 8 in indices times 2 power n minus 1. So that gives us 2 power 9 equals to power minus 8 plus n minus 1. Again, we are having the same base, which is 2. We can compare the numerator, the power, by saying 9 equals to minus 8 plus n minus 1. So 9 plus 8 plus 1 is n. Therefore, our n is actually 18. In other words, the entire number of terms in this GP, starting from 1 over 256 and ending with 512, are 18 terms in all. After having said that, we can now go ahead and safely use n as 18 to compute the sum of the entire GP. Also, we stated that what S18 is what? A, which is 1 over 256, R, because it's the first formula where R is more than 1. So 2 to the power of 18, then minus 1 over, again, R is 2 minus 1, which of course is 1. So you're going to have 1 over 256 multiplied by 2 power 18 minus 1. It's also permissible to make the answer this way because basically 2 power 18 is so humongous. But that's the answer, very acceptable. And with that, we come to the end of that question 2 as well, which is a bit different from question 1. Because in question 1, the number of times n is given directly. But in question 2, we need to first seek out what n is before we go on. So, we move on to question 3. Question 3 says, how many terms of the series I've got 3 plus minus 6 plus 12 plus and so on and so forth are needed to make a total of 1 minus 2 power 8. And that's the question there. How many times of this series, starting with 3, minus 6, and 12, will be needed to give us a total after adding from the beginning to that particular number of minus 1 to 8. Now, this is pretty much straightforward really as well. So we list parameters A being 3, and again, R, of course, this sequence is determined to be a GP. R of J is actually minus 2 because we have minus 6 over 3 is minus 2. Likewise, 2 over 9 is minus 3. So what we are seeking now is n. And we have Sn to be 1 minus 2 raised power 8. So the formula to apply here without wasting time is the second formula because the common ratio is minus 2, which clearly is less than 1. Or 1 is more than minus 2. So we say Sn equals to 8 bracket 1 minus r power n over 1 minus r. So sorting it directly, Sn is 1 minus 2 power 8 A is 3. Then we have 1 minus common ratio is minus 2 power n, which we don't know, over 1 minus common ratio minus 2. So that's still 1 minus 2 is on the left hand side equals to 3 bracket 1 minus 2 power n over 1 minus 2. That's going to be 1 plus 2, which is 3. So essentially, these 3 cancels out. We left with 1 minus 2 power 8 equals 1 minus 2 raised to power n. Okay. And there is how far we can go here to just do comparison here. If you look at both sides, we can take away 1. And it's 1 minus 1 minus 2 power 8 equals to minus 2 power n. 1 minus 1 is clearly 0. We are left with minus 2 power 8 equals to minus 2 power n. So this dividing both sides by negative, we have this minus there cancels to minus there. We have 2 power 8 equals to minus 2 power n. By comparison with powers, n is equals to 8. That means 8 terms of this sequence we add them to give us 1 minus 2 power 8. Now let me make a quick observation here. Normally, we have a negative value here. The power determines whether the answer is going to be positive or negative. If the power is even number, you're going to have a positive answer. If the power is negative answer, it's an odd number, you're going to have a negative answer. And the fact that we have a minus here, and at the end of the day, we have a positive value here, that means that n can freely assume the value of 8. Otherwise, it's not going to be. But basically, we are not meant to compare minus 2 power n with 2 because that's the same base. Because of that proviso, that for us to have a positive answer, we have an index of a negative value. That index must necessarily be an even number. And with that, we can safely say that there are 8 terms that will be added of this sequence to give us a total of 1 minus 2 power 8. And that has been the end of the lesson for today, which I believe you found quite super interesting, much as I did and fun. Thanks, stay blessed and stay tuned.